What if I told you? The smartest AI models on Earth are no longer designed just to talk back. They're being built to think, remember, and act on their own. One company dropped a trillion-parameter monster that can code, plan, and solve problems like a junior developer. Another quietly rolled out a memory system so powerful, it could permanently fix AI's most frustrating flaw. And while all that grabbed the headlines, a third player launched something smaller, but faster, capable of reasoning through entire books in minutes, even on a single GPU. Something big is shifting in the AI world, and you're about to understand what it really means. This isn't just another product release. This is a signal. The AI race is evolving again. And this time, it's not about who sounds the smartest, it's about who actually gets the job done. Welcome back to WorldScope News. Let's break down the future that's already here. Let's start with the biggest shockwave in the industry. A company called Moonshot AI just dropped a next-gen model called Kimi K2, and it's not your average chatbot. This isn't about flashy demos or poetic responses. This model is built to get things done. Here's what makes Kimi K2 an absolute beast. It has 1 trillion parameters. Let that sink in, 1 trillion, but instead of using all that power at once, which would melt your GPU into lava, it uses a smart system called a mixture of experts. Only 32 billion parameters are active for each input, so you get massive intelligence, but at a fraction of the cost and compute. This model was trained on over 15 trillion tokens. That's a mind-melting amount of data, code, text, images, multiple languages, and media formats. You name it. And to keep it from collapsing under its own size, Moonshot built a custom optimizer called Clip. This optimizer dynamically adjusts how attention is calculated during training, meaning it actively balances and stabilizes the model in real time. That's a breakthrough most people miss, but it's one of the reasons this model actually works at scale. Now, here's where it gets really wild. Kimi K2 isn't like GPT or Claude where you ask something, and it hands you a wall of text. K2 was designed for autonomous action. It doesn't just explain things, it can figure out what tools it needs, pick them, chain them together, fix bugs in its own code, analyze data, and complete a task start to finish. Let's say you asked it to analyze marketing data, clean the results, visualize trends, and write a summary. Most AI models would give you advice. Kimi K2 does it. It was trained in simulated real-world tasks, where it had to complete workflows without help, like a junior developer solving tickets on its own. That's more than smart, it's useful. This is the move from talking machines to working agents. But intelligence means nothing if memory is short. And that's where K2 shines again. This model supports 128,000 tokens of context. To give you perspective, that's about the length of 2 full novels. It means K2 can follow massive conversations, long documents, or complex project timelines, without forgetting what happened on page 1. Each token goes through 8 specialized expert modules out of 384, plus 1 shared expert for global context. The attention is spread across 64 heads, so it's fast, efficient, and accurate. In simple terms, K2 can remember more, do more, and lose less during long tasks. This matters for enterprise use, long-term planning, legal analysis, multi-step code, and more. Moonshot released Kimi K2 in 2 forms. Kimi K2 Base, a raw, powerful version for developers who want full customization. Kimi K2 Instruct, a tuned version that's quick, responsive, and production-ready out of the box. So whether you're a researcher building something unique or a startup looking for plug-and-play AI, K2 gives you both lanes. And performance, it's no slouch. On the SWE bench coding task, it scored 71.6%, just under Claude Sonnet 4. On TOA 2, a test designed for autonomous agent workflows, it beat GPT 4.1 with a 65.8% score. And on Codebench Live, it hit 53.7%, again outclassing major competitors. Heavy math, no problem. K2 nails 97.4% on Math 500 and 89.5% on MMLU, a benchmark for real-world reasoning. It's consistent, efficient, and sharp. Now let's talk money. Right now, if you're using premium AI like Claude Sonnet or Gemini 2.5 Pro, you're probably paying $3 to $15 per million tokens. Moonshot slashed those prices dramatically. Input cost, 60 cents per million tokens. Output cost, 25 cents per million tokens. That's more than competitive, it's disruptive. And guess what? K2 also supports local deployment. That means you can run it on your own infrastructure, without handing over data or racking up cloud fees. For dev teams, enterprise clients, or privacy-first platforms, this is huge. Here's the deeper shift that most people overlook. AI used to be framed as a smart assistant, a tool that helps you think. But Kimi K2 acts more like a junior engineer. It executes. In one internal Moonshot demo, the model connected 17 tools in one workflow, completed a task independently, and made decisions without being told what to do next. It's no longer, which model sounds the best. It's now, which model can finish the job. That changes everything, and because K2 is open source, the innovation isn't limited to big tech companies. Startups in Europe, labs in China, solo devs in Brazil, everyone now has access to a trillion-parameter foundation model, with local control, customization, and full deployment rights. That's how revolutions start. But there's one massive problem still haunting most AI agents. They forget. If you've ever chatted with an AI assistant, you know the pain. You mention something important, and it's gone 5 minutes later. That's because most language models have no persistent memory. The context is limited to what's in the current prompt. Once the window closes, the information is lost. So developers started duct taping memory solutions, saving chat logs, reloading history every session, shoving thousands of tokens into each prompt to simulate continuity. The result? Sky-high token costs, sluggish responses, and something worse, context rot. That's when your AI starts to contradict itself, misplace facts, or misinterpret what it just read, because it's overwhelmed by irrelevant details. It's been the first reason why AI agents feel more like toys than tools. Now imagine if your AI could remember you. Really remember your preferences, your projects, your name, even that almond milk coffee order you mentioned last week. That's exactly what Google just launched, almost under the radar. It's called the Vertex AI Memory Bank, and it's tucked into the Vertex Agent Engine. Here's how it works. As conversations happen, the Gemini model quietly listens in the background. It scans for durable facts, the kind of things a real assistant would jot down: shipping addresses, allergies, project details, birthdays, favorite brands. Each of these facts is saved under a scope, maybe a user ID, a project tag, or a specific device. This isn't sloppy memory, it's partitioned, organized, and recall-ready. When the user comes back later, whether it's the next day or a month later, the agent doesn't scan 50 pages of transcript. Instead, it sends a targeted query to Memory Bank, retrieves just the relevant facts, and integrates them instantly. No lag, no duplication, no extra effort. It even handles conflict resolution, duplicate merging, and topic prioritization using an algorithm Google just presented at ACL 2025. The result? An AI that knows you, that grows with you, not one that forgets your name between sessions. Let's bring that to life. A healthcare bot remembers that a user flagged a soy allergy last month. So this time, it recommends alternatives without needing a reminder. A beauty AI tracks that someone's skin goes dry in winter and changes the product suggestions seasonally. A project assistant remembers your team's naming convention and keeps it consistent across files. No prompts, no scripts, no reruns. That's what real memory looks like. What makes Google's Memory Bank even more appealing is the sheer ease of integration. It's not some complex dev operation that requires a week of back-end work. Instead, Google baked it directly into the agent development kit. All it takes is a single configuration flag, one line of code, and boom. Your agent now has both short-term memory for conversations and long-term recall that persists across sessions, devices, and time. For developers not using the Vertex agent engine, no worries. Google made the system interoperable. You can use simple REST APIs to read and write memories from any environment, whether that's LangGraph, Crew AI, a custom Python agent, or your own in-house stack. Even better, Google offers an Express mode for early adopters. Just sign in with a Gmail account. No cloud setup, no billing complexity. Stay within generous free tier quotas and experiment with persistent memory without spending a dime. Only when your traffic grows, or if you hit regulatory needs, do you scale into full cloud infrastructure. That frictionless path is what makes this so much more than a research toy. This is now a production-ready feature. Let's take a step back and really understand the implications of this. Memory doesn't just make agents more convenient. It completely redefines what an agent can be. Think of it like this. Right now, most AI agents are like interns with short-term amnesia. You train them every day, feed them documents again, remind them of every task detail, over and over. But with real memory, you're hiring a real assistant, one that learns, retains, and adapts over time. It remembers patterns. It builds context. It improves workflows. Over time, the system learns to think the way you think. Imagine a chatbot that remembers your calendar preferences, your writing style, your design tastes. Or a legal AI that adapts to the way your firm drafts contracts. Or a sales assistant that tracks every lead interaction and automatically adjusts follow-ups. That's not AI as a tool. That's AI as a team member. And now, thanks to Vertex Memory Bank, that vision isn't theoretical, it's here. But hold on, while Kimi K2 and Google's memory engine dominate the headlines, there's a whole other category that matters just as much. The lightweight speed demons. Because let's be honest, not every workload needs a trillion parameter monster. Some tasks need speed, cost efficiency, and the ability to run on basic hardware like laptops or single GPU servers. That's where Microsoft made its boldest move in months. And hardly anyone saw it coming. While the AI giants were busy bragging about size, Microsoft doubled down on efficiency. They've released something called Phi-4 Mini Flash Reasoning. It's a slim, sharp, 3.8 billion parameter model designed not to flex power, but to outrun it. The magic here lies in its design. Instead of using the typical full-stack transformer attention everywhere, Phi-4 Mini uses a novel training method called Samba-Y. This blends two architectural ideas: traditional transformer decoder blocks, state space models with gated memory units. Now, these gated units act like checkpoints. They allow the model to remember patterns across long sequences without burning compute. That means it can process long texts, multi-turn chats, and big documents while staying fast, and more importantly, cheap. Let's talk performance. Thanks to Samba-Y and the gated memory units, Phi-4 Mini Flash Reasoning can chew through 32,000 tokens of text up to 10 times faster than previous models of similar size. That's insane speed for a model this small. It supports attention windows as small as 256 tokens, which would normally cripple a large model. But thanks to the design, it maintains accuracy and reasoning quality without falling apart. And in tests, it's crushing expectations. On Math 500, it scored 92.45%, beating models much larger than itself, including QWEN 1.5b and STR-ATO7b. On AME24, a reasoning benchmark, it solved over 50% of the problems, again, ahead of its class. And all of this without any RLHF or human feedback fine-tuning. This thing was built right from the inside out. Let's be real, in the AI world, size gets attention, but deployment wins the war. Phi-4 Mini is easy to run. You can load it on a single A100 GPU, a modest workstation, even cloud platforms with tight compute budgets. It handles 64,000 tokens, processes legal documents, financial reports, research PDFs, at speed. Microsoft also open-sourced everything: model weights, training code, tokenizer, flash attention configs, and it's all available on Hugging Face. Download and deploy in minutes. Use it to build internal assistants, chatbots, summarization tools, or even full agents that run locally with memory. That's the game here, accessible power for everyday builders. So let's put the puzzle together. We're now in an era where AI systems are diversifying rapidly. Moonshot K2, a trillion-parameter open-source agent designed for deep action and full autonomy. Google Vertex Memory Bank, a durable recall system that gives agents real continuity and persistent intelligence. Microsoft Phi-4 Mini, a lightning-fast small model that makes deep reasoning accessible even on lean hardware. Each one solves a different pain point. K2 fixes action, Vertex fixes memory, Phi-4 fixes cost and access. Combined, they offer a glimpse at the next AI stack. A world where agents are smart, fast, scalable, and most importantly, independent. This is the real story. We're witnessing a shift from conversation to collaboration. Until now, most AI was reactive. You asked, it answered. But now, with models like Kimi K2, we're talking about proactive agents. You give a goal, and it executes the entire workflow. It picks tools, writes scripts, tests the outputs, adapts to failure, and delivers results, without asking for help at every step. It remembers context, it adapts to your needs, and it improves the more you use it. Imagine telling your AI, I need a dashboard with this week's traffic, user feedback, and cost breakdown. Clean it, visualize it, and share the file with the marketing team. And then, it just does it. That's no longer sci-fi. That's K2 plus Vertex plus tool access. That's the new age of AI. Now for the real question. Who does this benefit, and who should be worried? The winners: developers building agent-first tools, startups solving real-world automation challenges, enterprise teams tired of high cloud bills and short-term memory, and even solo creators who want better AI, cheaper, faster. The losers: closed systems that charge premium prices for basic features, AI models that are still just fancy parrots, tools that forget everything and start over with every session. This isn't just a tech upgrade. It's a power shift, from the centralized cloud giants to the distributed open source movement. From text generators to autonomous action machines. From limited memory to contextual intelligence that evolves. But with great power comes real concerns. What happens when every team, startup, or individual has access to trillion-scale models? What happens when agents start running critical systems without oversight? What happens when AI memory gets too good and starts storing things we didn't mean to keep? We're heading into a new phase of AI development, one that demands ethics, transparency, and limits. But if built right, this could be the moment where AI stops being a tool and becomes a true collaborator. One that helps us write code, understand the world, handle complexity, and maybe, just maybe, give us back our time. Here's where it all lands. You now have options. Want power and autonomy? Start exploring Kimi K2. Need long-term memory for agents? Integrate Vertex AI Memory Bank. Looking for something fast, light, and private? Try Phi-4 Mini Flash Reasoning. Each of these solves a different problem. Together, they redefine what's possible. And now, it's up to you to choose what kind of AI you want to build. Because we're no longer in the era of one-size-fits-all. We're in the era of intelligent stacks, personalized workflows, and AI that does more than just talk. Thanks for watching WorldScope News. If you found this breakdown useful, make sure to hit that like button, subscribe to the channel, and drop a comment below. Which of these breakthroughs excites you the most? Is it the trillion-parameter action agent, the persistent memory architecture, or the blazing fast local model? Let's hear your thoughts. And remember, this is just the beginning. The AI stack of the future is being built right now. Stay curious, stay sharp, and we'll see you in the next one.